Hello everyone, it's 3 o'clock. I'll make a start. Latecomers can join in, can't they? My name's Clifford Agius. I'm here to talk to you today about a project I've been working on for probably just over a year now, on and off. As you can see on the table, it's not complete, it's not finished, it's not fully working, it's not fitted to Kayden, the person I'm trying to build it for. But I'm here to talk to you about the journey that I've taken to get here, where I'm at the moment, the reason I've gone down the route that I'm going down, and what I'm trying to give back to the open source project. I'm going to go through it and hopefully, get some people involved in helping out in the project. So, but a bit about me first. I'm a developer. I was years ago. I then went and learned to fly planes, and that's my office to get to fly 787s around the world. I don't spend all my time developing, which is why this takes, it's taken quite a while to get to where it is, because when I'm not flying planes, I'm writing software for customers and clients. I did want to try and get this done for Christmas, but a customer gave me a project and I had to do that instead. Passions, I love coding, I love electronics, I love IOT, anything to do with that. Love learning new things. So this has been a real eye-opener on some of the stuff that I've had to learn, especially Bluetooth. I like helping people do things differently. Enjoy cycling, family, wife, 3 boys, 2 dogs. And yeah, so meet Kayden. Now Kayden is 14. He turns 15 in May, and I'm desperate to give this to him as a birthday present. So watch me on Twitter, and hopefully you'll see that. As you can see, Kayden has got no left arm from there onwards. His right hand is missing 2 fingers, and yeah. So, but you can see he's full of beans. He's full of life. He's a happy-go-lucky child. He's really fun, always joking, always laughing. He's got a very close-knit group of friends. He's a son to some family friends of ours, and he's been trying to get an arm. The NHS give you one of these. So it has a hook on the ends. He wouldn't loan me the hook because he's only got one, and he kind of wants it. But as you can see in the picture, this is Kayden going to the Paralympics back in 2012. The hook, this is the only picture I could get really with it in, has got a wire that comes out the ends, up across the back of his shoulders, and to open and close the hook, he moves his right shoulder. It's not really ideal, is it? It's not, it's 2019, we should be able to do better. You can also see that the NHS provision for these is, I've got the one from about a year ago. Prior to that, the brown, red and brown one is what he had. You can see the size and difference in the aperture, the opening, the bit where he sticks his arm into. So he has to wait until it doesn't fit and it physically hurts. Then he goes along to Roehampton, sees the doctors and nurses there. They're really good. They say, yep, we'll give you a new one. They take a mould of his hand, or his arm, here, and send that off, and a month or 2 later he gets a new arm. He goes down to Roehampton, collects it. But it's too big for him when he initially gets it. She has to wear a couple of socks to make it fit. And I know Mum always says, oh, you're growing into it, it'll be fine, don't worry about it. But this is a bit ridiculous, isn't it? It's made of fiberglass, but I'll pass it around, and feel free to pass it back and around. That can go around as well, I suppose. But it's quite heavy. Imagine putting a hook on the end of that as well, which is made of steel so it doesn't break. And you've got the moment arm of the extra weight on the ends. Yeah, it's quite heavy, it's not ideal, it's not perfect. And Sharon and Paul, his parents, kept going on and on about, it'd be really good if there was something a bit better than this, something we could, give Kayden to make his life a bit better. And then a couple of years ago, there was an article on the BBC News and Sky News, etc., about a dad that's 3D printed an arm for, I think it was his daughter actually, in his garage. And Sharon was talking about it at school, and she goes, "Yeah, Cliff, you've got a 3D printer." And I said, "Well, I have actually." And it's, "Well, can you help?" I was like, "You know what? Hold my beer. Let me get to that." So I was like, "Excellent. Right, what can I do?" So just to show what Kayden can do with his current arm, I asked him the other day to make a little video, and hopefully this will work. So you can see the hook. You can see you can't really see it in the film, but he's moving his arm, his shoulder back to grab stuff. but he's gotten quite used to it. You can see he's quite dexterous. He's picking out a tea bag, right, maybe two. So you can see it goes on a bit, but I'll stop it there anyway. But so I went to the internet, as you do, and looked up on, hold on. There we go. I looked up around the NHS, looking around. This was a year ago I looked. This is the live website. Yeah? Useful links. I was like, oh, great, thanks. Yeah, loads of help. So, you know, went to Bing, then Google, and Yahoo, and all the others. And basically, I found the website, Team Unlimited. It's kind of, yeah. And they're a team of people, you know, people sitting in their garages in their sheds at home that have got 3D printers that are printing these for, you know, their family, for their sons, their daughters, cousins, and stuff like this. So I went along and see this website. I was like, excellent. That's the one that's been talked about on the BBC, on Sky News. So at the time, I have a 3D printer that was fully working, fully functional and capable of printing these parts. So we got this. We live in Shepperton, quite very close to Shepperton Studios. So some people at Shepperton Studios that do have a very good 3D printer printed this for us. I'll pass it around in a sec. But you can see it goes into the end of the arm with the hook, the same one that connects to his hook. And when he moves his shoulder, the bit of wire closes the fingers. But as you can see there, it doesn't really close. It's got no way of picking something up, like a tea bag. It's not going to fit in the can to pick up a tea bag and stuff like that. It's just not going to work for him. So he used it for a day, decided that, no, that's not going to work. It's crap, I don't like it. You know, so, all right, fair enough. You know, 12, 13-year-old, you're not really going to tell them, are you? So, yeah, OK, back to the drawing board. What are we going to do next? I'll pass it around. There you go. Thank you. So, Open Hand project was one I come across. And Joel Gibbard is one of the team down at the university. Started up this company called OpenBionics now, but the Open Hand project was his early kind of foray into this world. And he came up with these electrically actuated hands. You can see there he's got a couple there, dexterous, etc., which he's, you know, he made the designs open source. Open source is awesome. So I downloaded the designs, looked at them, was like, oh, I could do that. That'd be OK. But then while looking around and just Googling a bit more about Joel Gibbard, I found his OpenBionics. You can see here, I mean, this is pretty awesome. You can see where they're building the parts and they come out with all sorts of design. That's Tilly, who's their poster girl. You can see they've built these hands to do some pretty awesome things. So I was like, excellent, right, we like that. Let's make one of those. So I spoke to Kayden, I spoke to Sharon, Mum, and said, you know, what can we do? So GitHub, gotta love GitHub, went there, and there's all the STLs with the 3D files to download and print. So downloaded them, and click print. Now my printer at the time, as I said, was pretty old and clunky and horrible. Quite a lot of Z wobble, that's up and down, and a bit on the Y-axis as well. So that's printing the fingertip of one of the fingers. You can see it's pretty poor, isn't it? It's not going to work. You can see all the layer changes. It was horrid. So what do you do if your hardware doesn't work? You upgrade, obviously. So that was my excuse for an upgrade. So I bought a Prusa Mark III. I had to wait for it because it had just been released and they weren't shipping them to the UK. But yeah, it's made in Poland. It's a phenomenally good printer. It's printed that hand, it's printed the socket and the other parts. Anyone has a guess how much that 3D printer will cost?
A lot. £3 grand?
No. £800. Delivered to my door. If you want it built, delivered built in a box, literally pull it out and plug it in, it's just over 1,000. It's 1,100, I think it is. Last time I looked. So yeah, it's awesome. It took me about a day to build. It's DIY. The instruction manual is super simple. So yeah, if you want a 3D printer, Prusa Mark III is awesome. So, got that, got the designs from GitHub, click print, and there we go. Got all the parts. That's what made this hand here that's on the bench. The springs, the screws, the dowels, the brass inserts were ordered online, and amongst those GitHub files is all the parts you need to buy them and where they buy them from. I found a few other places that were a bit cheaper, so I got the price down a little bit more. The motors that were inside, these Actionics motors, linear motors with potentiometers in, they're £50 each. So that was the most expensive part. Now you see all the white parts, they're all 3D printed. The red parts are 3D printed as well. Now all the white parts that are here, I've printed 2 of these hands, about 4 of these sockets which go on, and I'll come to them later. And I've probably got enough to print maybe half the parts for another hand. I've one spool, one kilogram spool of filaments, which costs £30. So you can see the cost here is dropping from £2,000 just for an arm from the NHS, and you've got to go and beg and plead to get an upgrade because it doesn't fit anymore, yeah, to a few £100s. So £30 for the plastic. And I've got the hardware, £200 for the 4 motors, so we're talking £230. Maybe another, I've bought loads of them, you know, because I wanted to make quite a few of these. And I'll come back to why later. Obviously, being a pilot, I travel the world, so all those parts there, probably about another £80 to £90, maybe a bit more. So we're talking less than £500, and I've got a hand. I've got nothing to control it yet, but we'll come to that. I've got a blank slide here for some reason. That's my 3D printer, printing the sockets, which is what was going to go on to Kayden. Yeah. See, it's got 5 hours and 45 minutes remaining. So I was like, it's fine, it's looking all right. It's normally the first bit that messes up. Excellent. So we go out to dinner. Me, my wife and the kids, and come back. It's like, let's go see the socket. Kids are all excited, they're 9 and 12. Go rushing into my office, and we see the mess on the left-hand side, and the socket at the back. It was like, oh no, what's gone wrong? So it printed enough. It fouled just near the top. You can see where it's hit the edge, and it fouled in it, but it printed enough. So we took that. Me and the boys went round to see Kayden. It was like, you know, does this fit? And no, it didn't. It was a bit too small. And the reason being is because what we did was we borrowed his other. So we borrowed this arm because he wanted to keep his one, and we put air drying clay inside. We took that out and then used that to model it. My oldest son, Macaulay, who is a whiz with graphic design and 3D modelling, designed it freehand in Fusion 360. I haven't a clue how he did it. Yeah. So it didn't fit, it was too small. So all we did was, in the 3D printing software, just told it to grow it by 20%. That'll work, surely. So we printed again. And it came out, it fitted, but it was loose. So we measured and worked out where it needed to be trimmed. So it needed a bit trimmed up there, 5 mm off there, that bit needed to go in a bit. So, you know, a couple of tweaks in Fusion 360. And it fitted. So that fitted perfectly onto his arm. He said it fitted better than the arm he currently he has from the NHS, from the hospital, from Roehampton. That part there costs 80p to print. How many hundreds, if not, you know, pounds do they spend making a model of Kayden's arm and then to send it off to get a fiberglass print? So, I've talked about the hardware. I've talked about how the journey of getting the plastic parts made. Obviously, that's the end of a socket, which is, and he's got hands. The bit in the middle we haven't quite got to yet. We'll worry about that a bit later once we've got the hand working, because I'm hoping it's just going to be a straight bar and we'll be good. So, obviously, we want to control it. So, OpenBionics, which is a company that developed this, produce a chestnut board, they call it. And you can buy those. It's Arduino compatible, you know, USB programming. It can actuate 4 modes, which is good because we need 4. It's got EMG, electromyography, and it's got force sensing. Yeah, it's a great wee little board. But they make these and they sell them for £250. And the problem is, I was like, oh, excellent, I'll buy one of those. So, yeah, go online, sold out. Okay. I'll do something else while I'm waiting for them to get more in stock. I sent them an email, when you get more in stock, we'll let you know. So I went on and looked and was like, okay, well, this board is good. What's this EMG stuff? You know, how does that work? Let's try and work that out. And that is basically sensing the muscle movements. So MyoWare make these little boards. There's one here. And that little board senses the muscle movements. So what you do is you put it on the muscle, and it gives you a reading. You can see the green one in the middle there is the one that's given the highest reading. Yeah?
What's EMG?
EMG, electromyography. So the little board gets all the readings and turns it into a nice analog signal coming out, which you can feed into an Arduino board, read that, and then control whatever you need to control. You know? So you see people doing it with a controller in a servo motor. Some people are doing it to control lights. You know, how much can you tense your muscle and see how much the bar goes up, you know, strongman kind of thing. Excellent. So we've got something now to measure the muscle. So how are we going to fit this to Kayden? Because his muscle group there is quite weak, because he's never used it. So, you know, how's that going to work? So, you know, the drawings on the MyoWare sensor is like, yeah, stick it to a muscle. So, okay, well, yeah. Not, my muscle's nowhere near as big as that, so it's not to scale, yeah? But, so we're going to stick it to a muscle. Excellent. So you stick the two prods in the centre mass of the muscle. The third prod goes where there's no muscle, and then it works out the difference and gives you a signal. So, okay, so that's the MyoWare website. So looked around a bit more. OpenBionics done some drawings about where to fit them to people with limited arm. So, okay, so that's going to go on the back, on the front of the arm. So how does that work? I'm just thinking to myself, well, you know, what are we measuring here? How's it going to work? So a bit further down the document, they talk about the fact that they don't measure, because if you open and close your arm, yeah, your hands, and you feel there, you can feel the muscle tense, yeah? So, but that's not going to work, because you're getting both muscles tense at the same time. So what they've done is moved the sensors round, yeah, and they've done it on the flexing of the wrist. See everyone doing it now, it's brilliant. So the flex of the wrist, yeah? So when the wrist is open, yeah, we measure that, and if they close the wrist and just twitch it, then it sends a signal to say, right, do the action of that grip, yeah? If they hold it for more than 400 milliseconds, yeah, so half a second, say, it moves on to the next grip in the sequence, and I'll come on to explain that in a moment. The board that OpenBionics, or the software that OpenBionics released, again, which is all open source on GitHub, has got 5 grips in it. So you've got fist grip, palm grip, tripod, pinch, and point gesture. And that's better than a hook. Yeah, don't get me wrong, that is pretty darn good. But imagine living life with only 5 grips. Yeah? It's not brilliant, is it? So I looked at it, I was like, yeah, that's like 5 grips, it's better than nothing. It's better than what he's got now. Let's go with that. And then I started thinking about it while I'm waiting for this board to come through. And I started thinking to myself, well, hold on, if you kind of twitching the muscle and then you hold it, it moves on to the next grip. So, okay, I'm starting off with a fist grip and I want the point grip, which is last. So 1, 2, 3, 4, 5. Oh, crap, I've missed it. I've got to go back round again. Yeah? That's not good, is it? They've only got 5 grips. What if Kayden wants another one? Now, I spoke to him about this, and I don't want to offend anyone, but at school, he said to me, I'd love to be able to tell my friends to, you know, go away. It'd be really good if I could say, Miss, sorry, the battery's gone dead. But, so that's the sort of thing he's asking, you know, he's a child, he's a kid, he's 14, you know. So he's sort of saying, oh, well, why can't we do that? All it is sensing the grip that's in play and saying, move to that position. Why can't we rearrange the grips? Why can't we add extra grips? Have 8 of them. All right, that's going to be even more to cycle through. Why can't we reduce down to just 1 grip? Because that's all he's doing today, and he's feeling tired. In the OpenBionics software, in the C codes that is loaded onto the boards, this is the grip array. You can see there, can you see at the back? You've got another screen, haven't you? Yeah. So you can see the grips that are there. It's a 3D array, so you can see on the left-hand side, it's got a 0 to 100. So basically in the software, it just has a counter that counts up over a given time. So you tell it how long it takes to action the grip, you know, a second, 2 seconds, and it will count up using a timer interrupt from 0 to 100. And as it gets, I'll use the pinch grip as an example, as it gets to 10, it says, right, move F0, which is the thumb, to position 700. These ones that are blank, it just looks, oh, okay, it's blank, so I'll just look at the last action, which is stay fully open. Yeah? So it gets to 40, and it's still move it to 700. So 700 is 70% of the way to full. Yeah? And at the end, move it the last bit and fully close the first finger and leave the others open. So basically, it's doing that. Yeah? Now, we're all software engineers now, aren't we? We can understand that. Yeah? It's not difficult. You know, it took a few minutes to work it out, go through, where does it get the counter from, what happens when it's blank, you know. You understand it because I've just explained it to you. You can look through the codes and, you know, work it out. But we're software engineers. This is our lifeblood. This is what we do. But someone that's, say, down in India, Pakistan, Africa, third world countries that are, you know, hoping to print these, they may not have that skill set. So I thought to myself, well, if you just delete, you can see I added thumbs to this array, just to prove a point. The thumbs will just do that, give you a thumbs up. Yeah? It's not in their actions. But, so I thought to myself, well, why can't we just add to this array or delete bits from it? It's just an array. It's just an object in memory. So I'll explain later how I'm hopefully going to achieve that. But you can see if you just want, say, 2 of the grips, you can command 2 grips and delete the rest from memory. You'll add more on. Train your own. Yeah? So the drawbacks, as I've been talking about, is the fact that, I didn't mention it, the muscle as well. Because Kayden's never used that section of his arm, his muscles are quite weak. So the MyAware sensor has got a little screw on the back of it, so you can turn the gain levels up. Yeah? As he starts to use it, because now he's going to be tensing it and twisting it and holding a grip, his muscle mass will start to grow over time, because that's what muscles do. So then the gain level is going to have to be tweaked down a bit. Yeah? Inside the Arduino software, the noise floor will need to be tweaked because there'll be less noise, because now his muscle's getting stronger. But for that to be changed, or for them grips to be changed, you've got to go back to OpenBionics, or whoever is a software designer that knows and has got Arduino installed and all the libraries, etc., to change those settings for them. Yeah? I want to make it easy. The grips are sequenced. You miss it, you go back around the loop again. It's not ideal, is it? Let's make the loop shorter. You know, have a mode. I'm at school, so I just want the pen grip mode and the sorry teacher go away mode. Yeah, you want to add your own personal grip. Yeah, whatever that may be, Rockstar grip or something. I don't know. So there were the drawbacks I see. Why I'm still waiting for OpenBionics to send me a board, because it's still not there. So I was like, right, okay. This has been a couple of months now. It's getting a bit embarrassing. I see Mum at school every day. How's the hand coming along? Well, I've built it. I'm waiting on this board. Really? Come on, you know. She goes to groups around the country that talk about limited limb children, and she meets Joel, and he's like, well, you know, we only make a few of them when we've got enough orders because they're expensive to make. They're bespoke boards. I was like, well, that's not good, because if we do get one now, and it blows up, something goes wrong with it, and I've blown that one up. If something goes wrong, you need to order a new part, don't you? Yeah? Now, I forgot. Shahid was, I was chatting to him on Monday, and I just got back from flying, just got back in from Muscat. I was tired, I was cranky, I was talking to my son, and I wanted to just test the board. So I plugged in a battery, just like this one, just to make sure the board's powered up and connected via Bluetooth. Didn't want the motors to move, so I didn't need the full battery pack. I just plugged that in. I've got a battery on my desk, which is 4.2 volts, not 3.7. And it's got a big cross on the back, and do not use. I picked the battery up, not seeing, plugged it in my tired states, and fried the board, because the battery was not only flat, but it was the wrong voltage. So the onboard charging circuit tried to charge the wrong voltage board that was flat. Lots of current, lots of smoke. But because I chose something that was easy to get, Amazon, a bit of tweeting backwards and forwards between me and Shahid. Don't panic, Cliff, you'll be fine. Yeah, right. I chose an Adafruit featherboard. Yeah? Has anyone heard of Adafruit? Yeah? Brilliant. New York City-based company. They make all sorts of electronics, lots of gizmos and toys, and they're sold around the world. The Adafruit featherboard, yeah, the one I bought on Tuesday, cost me, I think it was £28, I think it was. I bought it off Amazon at, what, 4, 5 o'clock? We was chatting, yeah? Click sends. By midday, the following day, yeah, the Hermes guy bashed on the door, there's your parcel, sir. Or more, it's like, kind of. So I've now got a replacement board. I was like, this is awesome. You know, that proved the point of why I've gone down this route of getting a replacement board. The other reason I chose a feather is because it's got the same footprint, yeah, as the Wilderness Labs F7 board, which is the .NET board that was kick-started. I've got 4 of those coming to me, hopefully, very, very soon. And my thinking is, well, let's get rid of the C and C++, which is Arduino base, etc. And let's put some .NET in there and have some .NET goodness. So that's the board I chose. This is the spec sheet of that board. So you notice we've got exactly the Atmel AVR chip set, the SAM21G18. It's 3.3 volts. It's got 8 PWM pins, got 10 analog inputs. It's got everything that the Chestnut board that OpenBionics sell. Yeah?
So in a nutshell,
Go on.
you couldn't get the £200...
£250 board, yeah.
They're out of stock.
Out of stock,
blah, blah, blah.
yeah.
So you've bought something for...
30 quid, yeah. Yeah, £30, yeah.
Which
is the same...
Which is completely general purpose that you can program to do
yeah.
the same thing as the Chestnut. That's
yeah.
where we're going.
Yeah, that's basically what I've done. So it's got all the same things, but as an added bonus, it says it there somewhere, it's got Bluetooth. Can't even see it now. I'm sure it said it somewhere. But yeah, there you go. But it's got Bluetooth. I was like, excellent. What does Bluetooth connect to? Ah, it connects to my mobile phone. So that's why I picked it. Because all those deficiencies I see earlier, I write a lot of Xamarin stuff. I thought to myself, excellent, I can use Xamarin. I can write a mobile app that connects to the hands and can move the grips around and do all sorts. Brilliant. We'll go down that route. But Bluetooth. Has anyone here worked with Bluetooth? Anyone here written software with Bluetooth? It's a pain in the, yeah, proverbial. You got the 2 flavours. You got Bluetooth kind of classic, as everyone tends to call it, which is your normal Bluetooth. It's what you use for streaming audio, your headset works on, stuff like that. You got Bluetooth Low Energy or LE or Smart, as some people call it. That is more for your kind of your heart rate monitors, more for your your key fobs, that sort of thing. You know, your temperature gauges, stuff that needs to send just a short burst of data every now and again. Yeah, and then it shuts down and doesn't drain any battery. That's why it's called low energy. So thankfully, the one on the Adafruit board is Bluetooth LE because I hadn't thought about that when I was getting it. So yeah, I found this data sheet where I was going through. When I was going through the data sheet, I found these facts the other day, and I just wanted to point them out because I thought that was quite interesting. Yeah, because back in December, my wife was getting an iPhone 6 battery change because of the old issue with the batteries and Apple and stuff like that. And it ran out at the end of the year. So I'll go and do it. Go on, off she went. But I spotted iOS 5.6, iOS 8 at the top. Yeah, the Bluetooth receiver or transceiver inside the iPhone 5.6, yeah, can send 6 packets of data at 32 kilobits a second. Yeah, it's quite good. iPhone 5.6 with iOS 8.2 is now rate limited to 16 kilobits a second. iPhone 5.6 with iOS 8 and above is 5.3 kiloseconds. Look at the speed difference. It's the same device. Why do you think Apple are doing that? To save the battery. Yeah, that's all they're doing it for, to save the battery. The Android phone, they only had, I don't know why, a Nexus 4, but 84 kilobits a second, you know. Now, I don't need to send the data very fast. I don't need to send a lot of data. You know, a couple of packets is more than all I need to control the hand. It's literally, you know, what, 4 characters, 4 ASCII characters to do the control that's needed. So it's not the speed, but I just found that very interesting, the way that, you know, big corporate like Apple are controlling your device by installing software that's slowing it down. But there you go. Anyway, I move on. So I've now got my Adafruit Feather M0 Bluetooth, which is this one here. There's the Bluetooth module. You can, Adafruit make these boards with Wi-Fi, with low energy radio. There's 20 or 30 different boards just with that part there changed for whatever transport medium you need. The other board on the left is a DC motor driver board that will drive the motors, because obviously we can't drive them for just an analog output. So that is a PWM board, and it works via I2C, which is basically a serial protocol that talks chip to chip. So the main board is now doing even less, because whereas the Chestnut board is controlling the motors directly, it now just sends a command across, says, tell the motor to go there. It can go back to doing other stuff, like talking to a mobile phone. But when I got these boards, they arrived, it's like, brilliant, excellent, I'm ready to go. See the flat cable that's there? And this is a standard pin for through-hole pin. So I've got to try and connect that flat cable to those pins. That had me puzzled for about a week how I was going to solve that, because what I didn't want to do was have to do too much soldering. I wanted to make this as simple as possible and as cheap as possible. Yeah, I'm thinking of places like India and Africa and places like that where they're not going to have the tools, the skills to maybe do some fine soldering. So what I've done at the moment is, you can see them just here, I've soldered on some fly leads onto a daughter board which is at the bottom. Yeah, and the idea is that daughter board has literally got about 20 connections going across the board, and then the 5 from each of these connectors. And my thinking is that that daughter board, once I've got it working, I'm happy with it, which is why it doesn't fit into the hand at the moment, I'm going to get it etched, put the etch design from Eagle up onto GitHub, and then people can download it and etch it, and all you need is some chemicals to etch it. Shahid was telling me he used to do it in GCSE in school, so it wouldn't be too difficult to etch one of these wherever you are in the world. Yeah, or just order one off the internet. You know, we'd probably get it done for less than $10. So that's my thinking. So now I've talked about the hardware. I've talked about the hardware as in the plastics. I've talked about the hardware as in the electronics. So I want to move on to a bit of the software now. I'm not sure if anyone wants to have a look at this, but that can be passed around as well. I'm not sure if it's been around already. So this is what I was talking about earlier. This is the OpenBionics software that they provide. You can download. It's called Beetroot. I'm not sure why Beetroot and away from nuts, but hey, it's their naming strategy. So you can see there, you can see where this one hasn't got the thumb in, but you can see there they've got extra points in now, so they can delay the action and you can do a bit more control. And there's nothing to stop you. I've already done it. You can add 99 parts to the array. So if you want to do fine motor control of doing something, then there's no reason why you can't. Just so you know, F3 and 4 are the hands moves. You've got F0 is the thumb, F1 is the index finger, F2 is your middle finger, F3 and 4 move together. And if you think about it, when do you ever try and move those fingers independently? I mean, a lot of people can't. So there's no reason to put an extra motor in, add extra weight, extra complexity, and an extra 50, 60 quid or whatever it is for the motor. So those two move together. So there you go. But, so I've downloaded their software from GitHub, uploaded it to the board, and it's like, ah, crap, now I need to make this extra DC motor board work, I need to add Bluetooth. So adding Bluetooth was painfully simple, because Adafruit being Adafruit, and Lady Ada, who is freaking awesome. I'd love to meet her and buy her a beer one day, because the stuff that she does with Adafruit is amazing. That is it. That's all I need to do for Bluetooth. Yeah. So BLE begin. I call my variable BLE print because I use it elsewhere and I know what it means then. Do a factory reset, and the reason is when it boots up, you want to reset the chip and make sure there's nothing weird going on. Hasn't remembered something from previously. Yeah. The echo command is in there because I was using that for testing. Wait until the Bluetooth is connected. Again, that will get turned off when I give it to Kayden. because at the moment the hand waits until it gets a Bluetooth connection before doing anything. Obviously we don't want that because his phone battery might be dead and he still wants to use his hand. We don't want to turn into a Tesla where you can't unlock your car, there's no Wi-Fi, do we? So, LED activity, there's little LED on the boards, and we basically just tell it to be in hardware mode, so it'll just flash, look in, and then go solid when it's got a connection. Again, we probably won't need that because that's just draining battery. And it's going to be inside the hand, so do we really need that? I'll probably turn that off. So you can see that lot can disappear. So all I need to do is do a factory reset, just because I want to factory reset it and make sure I've got a clean, fresh. Set the mode to data, because all I want to do is send data, yeah? And then I can print, and that will send out over Bluetooth, BLE connected, which the mobile app can pick up. That's all I need. So just begin, factory reset, and print. And I've got a Bluetooth connection from a piece of hardware that I bought for 30 quid, delivered by Amazon on Tuesday. And it's sending out Bluetooth commands over UART, which is a serial protocol. And then there's an app on the phone, which was harder than this. I wish it was easier to get a phone to doing a couple of commands, what I did there. Other parts of the software, in the initialization, this is where it attaches the fingers. So it attaches the 4 fingers, and the version they had the PWM pins in here. I didn't need those, so I just set them to -1. They're just unsigned integer anyway. So I set them down there, and they're the analog inputs, and that's whether they're inverted or not. I was messing around earlier because I went in my rush on Tuesday to resolder the new board into the old one. I connected one of the potentiometers back to front. So when the finger's open, it's given a reading as if it was closed. And I didn't want to play with it yesterday because, yeah, I thought I'd leave it. Yeah, the demo gods were being good to me at the time. So I changed here, and then on in the code that actually does the attaching and sends the signals to the DC motor board. There's some minor changes there as well. So I didn't start a stopwatch. Does anyone know how long I've got left?
Yeah, 20 minutes.
20 minutes, awesome. So I didn't need to make much in the way of changes to the software that's loaded onto the board. There's other changes that were made to things like the watchdog timer, etc., to make sure it didn't time out on me while I was doing some debugging. And just while I mention it, does anyone here do IoT stuff? A few of you. Do you use the Arduino IDE, or do you use VS Code, or do you use Visual Studio?
I don't develop software on the devices itself. I connect to them.
Oh, you connect to them, okay. Well, if you do decide that you want to get involved, or you do decide, actually, I really like what Cliff's done there, I'm going to go and build one myself. You can use the Arduino IDE, yeah? It's probably the worst IDE I've ever used. It's horrid. You do file open projects, it opens a new instance of the IDE and leaves the old one there. So you end up with all over the place. You can use VS Code, which is awesome, yeah? But I spend most of my time in Visual Studio. Now, you can just about make it out. You see up the top here, Arduino for Adafruit, etc., etc. There's an add-in you can buy off the internet. You don't even need to buy it. It's completely free. But if you want to stop it nagging you, I think every 5th build, it sends you a little message. You sure you don't want to buy it yet? It's £60 to buy. It's called Visual Micro, and it's just an add-in to Visual Studio. It's awesome. If you're going to do IoT work, I highly recommend it. Because then what you get, which you don't get with VS Code or with the Arduino IDE, is you get your breakpoints back, which is awesome. Because otherwise you're doing print statements to serial to try and see what's going on. So you get your breakpoints back, which puts us back in happy world, which is why the watchdog timer is turned off, because obviously the breakpoint will stop it, watchdog timer will time out, and it will reset the board because it thinks something's gone really badly wrong. So back to my slides. So now we've got the hand working with electronics. We've got it all built. And I said that I wanted to make things better with a mobile app. Yeah. Ollie McBride was the software guy that wrote all the software for OpenBionics down at Bristol University. He's done a fantastic job, but he's not a mobile developer. He's a hardware software developer. I like Xamarin. I spend a lot of time writing Xamarin for clients. and I want it to work on all the platforms. I want it to feel native to user. So if they've got an iOS or an Android, it's completely native to them. Yeah, they're used to swiping left or right and used to pulling down to refresh. It needs to have a Bluetooth stack. Yeah, some of the ones, the mobile paradigms, you can't get native access to all of the parts. One of the ones that Xamarin does do is the Bluetooth stack. Needs to be C# because I know C# and I can work in C# and I can work in C. I'm not a JavaScript developer. I never will be. And really important to me was accessibility. Yeah, and Denny's sitting at the front and he can tell you all there is to know about accessibility if you need to know. Great guy to talk to about that. But I wanted the app to have whatever accessibility options the person has put on their phone. Because Kayden's got no arm there and he's missing those fingers. So to him, his accessibility, he might have all the buttons bigger. You know, to him, that might be important. So I don't want to mess with that. I don't want to touch that. That's his world. It's his personal phone. With Xamarin, it will keep all that accessibility there. You know, a button will be whatever, because it's compiled down to Objective-C for iOS, and it's compiled down to the Java for Android. It will be native to the phone. So the phone doesn't know that it was developed with Xamarin and C#. You know, it just gets, you know, the APK files. So it was important to me to go along that route. So as I say, I picked Xamarin. Has anyone here done any Xamarin development? There's a couple of hands going up. There's a couple of shaky hands. So you've all seen this slide, haven't you? Those of you who haven't, yeah. So you got the additional one with shared backend, and the UI layer is individual for each one, so storyboards, etc. You got the shared UI if you go down the Xamarin Forms route. So you can write it all in either C# or declaratively in C#, or you can use XML to write the UI layer as well. I quite like Xamarin Forms because I find it, you know, I haven't got to worry about too much about going into iOS and then doing all again for the UI in Android, and do it all again in UWP. Or for a client recently, we did one for Tizen because they wanted some screens up, and they wanted an app developed that was the same on their phone, on the phone as it was on the Tizen screens through in the offices. And I was like, yeah, we can do that with Xamarin. And yeah, you can do it in a traditional. What didn't have a Forms plugin for a little while, but now they've added one. So it'd be a lot easier to do now than it was a while back. We're using the traditional route. But at Connect last year, David Ortnow, I said to him, I'll stick a picture up. Hi, David. At Connect, it talks about Xamarin Forms shell. Has anyone looked into that? No hands at all. The shell is basically another layer on top of Forms. So whereas with Xamarin Forms, you do your UI layer, and you have to worry about the navigation stack, you know, popping things off, popping them off, putting things on, popping them off, you know, and you have to think about the whole kind of flow for the app and navigation. And for a small app like this, it didn't really matter. But I'm a freelance developer. It's just me, myself, and I like to learn new things, as I said at the beginning. So I was like, well, this is an ideal opportunity to play with shell. Because it doesn't matter if it doesn't work yet. I can always go back and read that because I'm still building the hands. So I thought, let's give it a go. So what shell does is it's very opinionated on what you can and can't do with the navigation stack. Yeah. So you can have a single page app, bottom tabs, top tabs, bottom, and you have a flight menu. And it's like, well, that's all I need. I want a flight menu because I want them to select what they're doing. And, you know, bottom and top tabs would be awesome as well. You can go between different hands and stuff like that. I was like, excellent, let's look at Xamarin Shell. So, Xamarin Forms Shell. So, let me get, oh, hold on. I need to do that, don't I? So, in Xamarin Forms Shell, you have your normal XAML. Yeah, I just like doing it in XAML. At the moment, if you do Xamarin, who uses CSS in their Xamarin Forms app? Yeah, a couple of people. Yeah, I just find it, because I did used to do web stuff, and I just find CSS moves all this chunk of colour this, that colour, and colour that colour out and into a CSS file, and I can give that to someone who's a designer, not me, and they can make it look pretty, and then give me a CSS file back, and we can plug it back into the project. At the moment, you can't set things like the shell because it's in experimental. It's not been put into the CSS part of Xamarin Forms, but it's an open source project. If you want CSS to work for your shell project, let's add it. So, further down, that, the blue squiggies I mentioned in a moment, but that there, from fly-out header and the shell, is a navigation stack of my shell Xamarin Forms app. So I've got a fly-out header, and all I do is put a bit of padding around it, and then I put an image at the top. So as a fly-out header, the menu comes out from the left. It's got a little picture of the hand at the top, and then that's my shell. So I've got 3 pages in this app. I've got a Bluetooth connection, which opens up the list adapters view, which is over here. List adapters view. Sorry, it's in the views folder. And then I've got another one, which is the hand controller view. That's it. Navigation's done. That's it. That is all I need to do. Now, to get from the list adapters view to one that actually selects the Bluetooth device, which is called device connection, yeah, I didn't want that to be a button somewhere. I wanted them to go through the path to get to that page. So if you do that, all you need to do is in your shell.cs, which is the CS file, the partial class that backs the XAML, all you need to do is just register the root and tell it that if you see a device connection call, that's where you need to go. Create a new one of those and adds it to the stack. And it sorts it all out for you. It's done. That is it. Now, to make this happen, you know, the more astute amongst you will notice that I was using VS17 earlier because I needed Visual Micro to work. That only works in VS17 because it needs a stable version of Visual Studio. To make Shell work, you need VS19. Yeah? But I'm sure once VS19 is stable and released, I mean, what pre-2 came out a few days ago, didn't it? Then, you know, you can... I didn't upgrade. I wasn't that brave. But you can see that's there. You can also do things like the closed flyout is pulled out, yeah, and I've added a timer and set a timer up here. I want it to take half a second to close, yeah? So you can control how long it takes to open and close, yeah? Again, thinking about things like, you know, people with partial visibility, will they want it to stay open longer, you know, or to close quicker, for example. In the main activity, just back to the shell there, the reason that is, notice the difference here, this, and I did this for a reason. The shell item has then got a shell section, and it's got the content inside that section. Yeah? If you don't want to have these layered stack, you can omit the section and item and just put the content. Yeah? So all that allows you to do is, if I was to take that content and put it inside that section, when it produces the page, I'll end up with tabs. Yeah? So at the top of the page, or the bottom of the page, depending where you set it. So you can see there, I just want 2 pages in my flyout menu, independently selectable. And that's it. So even if you just want like 3 or 4 pages, you can get rid of the shell sections and just have lots of shell content. Bang, 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 bang. If you're doing it in declaratively in C# as opposed to XAML, you can build this in a loop. And if you look at the samples they have on GitHub, for one of them, they produce a shop. I can't remember what they call a shop now. It's not Tailwind. Is it Tailwind Traders? Yeah, the new one. So they can build the app, and they add items dynamically to the menu. So are you keeping track on time for me? Yeah, good.
10 minutes.
10 minutes, excellent. Good on time then. So the Bluetooth, the Xamarin developers know that you've got Xamarin Essentials, yeah? Now, when I was like, excellent, I'll just go to Xamarin Essentials, download it, install that, pull that in as a NuGet package. You know, you get your location, you get your Wi-Fi, you get your navigation, you know, you get all those sorts of good things that the team have put together. And I was like, I'll just go there. You know, Xamarin Essentials will have Bluetooth, you know, dot into it, and I'm good. No, it's not there. So I was like, oh, crap. I need Bluetooth to work. There's a plugin called plugin.bluetooth. Archie, I've forgotten his name, has developed it. It's really good. The only thing that I found and made me stop and think is it uses the reactive model. I hadn't used that until I started developing this. Having developed this now and seeing how it works, I'm like, this is awesome. I really like this reactive stuff. So you can see by doing some open source stuff, I've learned some new skills. I've enjoyed doing it. I'm hopefully going to make someone's life better. So open source is awesome. So you can see in the reactive, we create a, in the call to the view model, we instantiate everything. And then a bit further down, I just wanted to point this out, that's how awesome in that get adapter. Now the adapter is basically the Bluetooth chip inside your phone, yeah? Some devices have more than one adapter. Obviously, a mobile phone, it doesn't, unless it's got classic and Bluetooth LE. So I'm just getting the first adapter because my phone only has one. Yeah, that's it. If you can't find one, it tells me there's none there to find. But that's all I need to do. Behind the scenes, you know, the plugin, the NuGet, has just done all the hard work for me. The other thing is, because it's Xamarin, where's it gone? I did have all this bookmarked earlier and then promptly lost it all. Because it's Xamarin, it's in here. You can do the subscribe to, you can get connection state, which sends back what the state of the connection is. Send the UART string, which is basically sending the string from the phone to the device it's connected to. So it's just sending a message out, and it sends it as an ASCII string. So, and the device, the hardware device we've got there, understands UART connection, understands all the handshakes that go backwards and forwards, and that's it. So that's sending a string across. But here somewhere, got a pair to device as well, which is part of the plugin. So once the app's installed, you can click the icon, say pair to device, yeah, and it will pair with the hand. And you can add in there, I've not done it here, but you can add in there like a password. You know, when you pair something new, it says enter this password on your, you know, when you do it in the car, that sort of thing. So you can do all that as well. And it's all, again, part of this awesome plugin, which means that, you know, they can pair their hands, which means that then no one's going to take over the hand because it's paired with that device.
And it works for Android
and iOS, yeah,
and
yeah.
it's the same plugin.
Exactly the same. You'll notice that I haven't touched the Android or the iOS projects. I've left them closed. All I've needed to do in those, and for the Android app, was in the main activity, I need to do permissions. So Xamarin Essentials, I need to give the, where's it gone? There it is, Bluetooth. That's all I need to do.
So this is the only stuff that's different between the two?
Yeah. So in the main activity there and in the iOS project, it will have the same thing as well. So it will need that. If you're using Xamarin Forms Shell, because it's experimental, in each of the projects, you need to just set the flags to experimental so you can get to the experimental stuff. Otherwise, it won't show up. And that just highlights it so they can then use it. Otherwise, IntelliSense won't work and things like that. But yeah. So that's all I need to do in the Android and iOS app. So let's look at handy working. Where's he gone? So there's my app. I'm not a very good designer, so apologies for the So it's I've asked Xamarin Shell to put me straight into the list view adapter, but if I pulled it out, that menu, it's done the flight menu for me. Remember earlier I only had the 2 pages. There's my 2 pages. Bluetooth connection and grips. That's it. If I click on grips, it takes me to the grips page, and I've put the grips in there. You know, I've got a fancy one. I don't know what that's going to be yet. But wherever it is, I'm thinking the teacher to go away. Don't know. But there's the 5 grips that are in there, and then we add another button. I'm going to add, my intention is that that menu that's there will have quite a few things in there. So things like setting all the thresholds for the noise floors, all that sort of stuff will be in there, and maybe behind a bit of a password protected page so you can't accidentally change it when you're out and about. Maybe it's not a 13-year-old, it's a 6 or 7-year-old that, you know, mum and dad doesn't want them changing settings because they'll mess the hand up. So it'll be behind a parental password maybe. These are all sorts of things that I want to add to the app and give back to OpenBionics and the open source project. So you can see I did the flyout. I told you about the image that I put at the top of the flight menu. There it is. It's there. If I click outside the menu, it closes in half a second.
So those buttons for each grip, they suggest that it's just toggling on and off. You either got it or you haven't. But from what you were showing us from the array earlier, it suggested you might be able to do it fine grained.
Yeah, because all that will do is command that grip to open and close.
Right.
So that's all that will do. So it will send the command, which is just a UART string of, you know, action the palm grip, and it will action that grip. So when my idea is not to have buttons, is to have like a list view, and you can order them, and the way you order them and save will save it to memory, such that when he tenses his muscle, yeah, to switch between the grips, instead of having 6, you might only have those 3. So this is my thinking of design at the moment. He selects which ones he has engaged, yeah, and then clicks save, or, you know, have a button like that there somewhere.
It's still on or off. There isn't any question of there being any kind of graduated.
Well, that you put into the board, into the array,
That
yeah,
array.
that array.
How do you
So,
control it? So
what do you mean by that?
there's something I'm not getting. So because I'm thinking I'm him, and rather than just saying grip on, grip off,
Yep.
I want to be able to move the grip.
Well, that is where you control it in that array that we looked at earlier.
Yeah.
So you set up the array.
But is that
Yeah.
how do I control it? I'm not just clicking a button. How do I, as the
That's
person
with the muscle sensor.
with the muscle sensor?
Yeah.
Right.
So
that's-
like I said, when he'll twitch his muscle, yeah, and so basically he doesn't need the phone for it to work.
Yeah.
Yeah, but he could use the phone to set the hand up.
So that's about configuration.
Yes,
rather than
exactly.
control.
Yeah.
Right, okay.
So, and then he can, you know, because his phone battery might go dead. I don't want him to not have a hand. In fact, actually, we was talking about this the other day, and he says, with the battery pack is so large on my hand, and my phone goes dead, can I charge my phone from the battery pack? He says, because I can live without my hand, but I can't live without my phone. Fine, okay. And that's not hard, because it's just a USB port.
So
I've got...
Does the fine-grained control come from the muscles? Can with the muscles?
No, all you do with the muscle is say open or close.
Still on and off.
On and off. The fine control comes from that array, that 3D array, and how you set that up.
So it'll
Yeah?
happen gradually. You'll say on
Yeah.
and off, but it'll happen slowly.
How you build up that array, yeah.
Right.
So if you build up that array just so it's got 100 steps instead of 4,
Right.
you'll get the fine control of how it moves. Another page that I want to add is another page where you can actually create the fancy one, yeah? Where you can go in there and it'll be sliders where you'll say go to that position, the hand moves to that position, right? Save that point, next position, save that point, next position, save that point.
Yeah, like a slider for each finger.
Yeah, slider for each thing, exactly.
Like
Yeah,
a GUI for
Yeah.
that array.
yeah. And then
Which
once it's
answers
done,
the question about people who don't know
Exactly.
arrays and C#
Exactly,
and
exactly.
Java or whatever, they just do it with a slider,
Yeah.
save, away
and
you
it
go.
puts it into the EEPROM,
Yeah.
so saves it into there, or flash in this ball, because it's got no EEPROM. So saves it in the flash, and next time the hand boots up, that will be in the array. You can set up to say, in fact, every time you boot, only have those 3 fingers, those 3 grip in the array. Okay, it's booted up. Okay, you need the phone to maybe change them. It's still stuff that I'm thinking through and trying to work out. And I know it's going to change. This is a project that I'm working on and building. I'd love for some help.
And I guess you've got to get the thing done on basic so that he can start using it.
Yes, that is the plan. His birthday is in May. I'd love to give it to him for his birthday. So
have you got this? Have you got the motors in here?
yeah,
See
it's
the
all.
hand?
I'm just about to. So I've just done
Got
search for Bluetooth. You can see it's gone for the adapters. It's found the Adafruit Bluefruit. You can rename that if you want. I haven't yet. So I select the one I want. You can see it's connected. Good thing about Bluetooth LE, it connects in under 3 seconds. Yeah, it's phenomenally quick. Classic Bluetooth takes a while. You have to pair, etc., etc. At the moment, I'm just sending basic UART commands. So if I send to turn it on. So that's the hand on. It's a bit of a whining from it at the moment, and the reason for that is you have to set the PWM frequency, and you have to find the right one for the motors you got. I've not tweaked it enough yet, so you can make it quieter and do that. So if I go to...
That's the PWM working that we can
Yes,
hear there.
that's the PWM working there.
If you be on the webcam.
Ah, yes. So the people at the back can see. Thank you.
Yeah.
I might go over by a minute. I just want to show you. I want to show you it work. Yeah, I want to show you it working. So if I go to here, and oh come on, why is my keyboard not coming up on my phone? Is it because the keyboard's disabled in this VIO thing? Not that one. That one. Can I type in there? Ah, it is. Okay. So I drag that over to there, out of the way. So the command just to do a grip is just G0, yeah, and that's grip 0. And it should. I've got to click send. Wow. That's it. So, thank you. I'm hoping that, and if I send the same thing, it opens back up again. So you can just keep send. you can keep...
5 things. We can do G1 for the...
Yeah, we can do different ones than that. So, but the only one that's working at the moment is G0 because that's a hello, goodbye. Yeah? And the reason for that is because, if you remember, I told you I burnt the board out and I connected it up, and one of the potentiometers, the one for the thumb, is back to front. So if I tell the thumb to close, it'll open, and the software is not going to cope with that. So I need to fix that when I get home. So back to my slides, just to finish off. There you go. So I've talked through Xamarin Shell, which I think is awesome. I think it's the way it's going to go because it makes the plumbing of Xamarin, and the plumbing, especially of Xamarin Forms, so much simpler. You haven't got to worry about that. What's next? Design and build the ARM. Macaulay, my eldest son, who's desperately trying to get into the games industry and graphics design and stuff like that, he's using this as a bit of a project. He's building the ARM. Yeah. So we've got the socket. The socket works. We want to connect the end of this to the end of the hand. Yeah. At the moment, we've got a little table mount, but we're going to connect the two together. We did talk about putting the batteries inside the ARM, but obviously, anyone who knows anything about science, if you move a weight further away, I can hold that. If you put a 10-kilo weight down, I'm going to be... So what we're going to do is put the batteries underneath his elbow there, so it's part of the weight of his arm. So it's this muscle that's going to take that weight, not that muscle there that's weak at the moment. Redesigned the back cover. So here's the back cover. That came off the printer this morning. I got up at 6 o'clock this morning and the printer had just finished. Thank God. But I got here, I need to find that the inside contour there is catching the board, and I didn't want to crush it in there and the board to go bang, so I left it off for the demo. Plus, I think actually if you get to see the electronics, you might get to understand it a bit better. Work out the best way to fit the battery pack. We're thinking of putting it there. We don't know yet. We haven't tried it. We're going to give it a go. We talked about just using elastic bands and holding it on for the moment and see if that works, how he feels. Yeah. Build out the Xamarin app. We've got lots of ideas. An idea I met, and I'm crap with names and I've forgotten his name. He gave a talk yesterday about ML.net. We were sitting in the hall conference yesterday, sitting there having a coffee and a bit of cake, and he was talking about ML.net and trying to explain it to my little brain. And he was talking about, I was saying about the muscle sensors, about the gain levels being wrong and about being able to change it in the app. He was like, well, if you could send that data to the cloud and just store it in a blob storage somewhere up in the cloud, it's anonymous because you don't send any data up with it, just the readings. Yeah, you got a phone, so there's enough storage on the device to hold it. Bluetooth it to the phone, send it to the cloud. Get someone who's clever with ML.net to then reason over that data and say, actually, your gain level needs to be changed, and you need to change it by turning the screw on the muscle sensors, or you can change it by changing the settings in the phone app. I thought that was awesome. And that is why I love conferences like this, because you get to meet people like that, and they come up with an idea that you think, actually, that's a great idea. I don't know how to do it. I haven't a clue about ML.net and machine learning. But it may be something that I can entice someone to help along the journey. But building out the Xamarin app is something I'll do, but what I really want to do is get this finished, get it on Kayden's arm, get him using it, and I can build the app later. So that's the plan. The other thing I'd like to do is the Meadow boards from Wilderness Labs. If anyone went to the keynote with Scott Hanselman this morning, he showed off the Meadow board. I think I was Kickstarter number 100 and something. I bought 4 of these boards. I'm waiting for them to arrive. But you notice the platform is identical to the Feather board that I fitted. Right. And my thinking is, unplug the Adafruit board. This has got built-in Bluetooth. It's faster, it's quicker, it's .NET. So all the .NET goodness and the run, the full stack of doing breakpoints and debugging the code can run on the Meadow board. Yeah, it's a little bit more expensive, but it's a great board. So I'm thinking about fitting that. And it's got, as we can see, there's the Arduino, but it's got Bluetooth LE built in. It's got all these extra bits and bobs, a bit of security. So if you wish to help, I'm putting all of my code that I'm writing and playing with and doing up on my GitHub. For the Xamarin app, it's called Handy App. OpenBionics have got the beetroots. My version of the beetroot software, which has been hacked about to make it work for the Feather board, is on my GitHub. I should have put the link here, I didn't. But if you just go to it's an open project. If you want to dive in, you want to do pull requests, you want to suggest something where I've gone wrong, I'm an airline pilot, I'm a developer, but I could do with the help. If anyone wants to jump in and help out, please do. If you see something you think actually would be really good if you add this to the project, suggest it. I'm going to give everything I've done back to the open source OpenBionics project for them to give out to children in the future. And hopefully we can change it from being a crappy arm, which costs a couple of £1,000, doesn't do much, to the OpenBionics hand costing 10 to 15,000, yeah, to actually something that costs a few £100 and children around the world can see it. That's me. Thank you very much for coming. Hope you enjoyed it. Thank God it worked.